hydrogen ion and a HCO3. Okay? And on this side of the equation, it's going to break into the stream-to-mode way. H2O plus CO2. The little pluses represent hydrogen ions, okay? And the boxes on this one represent a buffer, okay? So on this top container right here, we have a cup of pure water, all right? Just pure distilled water. We check the pH of 7, right? All right. To that pure water, we add a very strong acid. You know, we mix the strong acid with the 7, and it lowers our pH to about 3.4. All right. You cool with that? So we took the neutral substance, poured an acid into it, which made it very acidic. Okay. Now let's say we have an equal sized container full of blood. Okay. First of all, that'd be kind of creepy. All right. If we had an equal sized cup full of blood, and we poured that same amount of acid into that cup of blood, the blood has buffers in it. Okay. So instead of it dropping from down to 3.4, it's only going to drop it not even a whole point. All right. So the acid took the water from pH of 7 down to a pH of 3.4, but it took the blood from 7.41 down to 7.21. So those buffers prevented the excessive acid from lowering the pH of the whole system.
So if you were to keep adding acid to blood, it would still continue to drop?
To a point, yes. Well, yes, it will continue to drop. If you keep adding acid, it will continue to drop.
Very slowly.
Right, and you're going to reach a point where your body's not going to be able to compensate for that.
But I assume they take a good bit.
All right, so what was that?
They'd probably take a good bit.
Yeah, take a good bit.
Like time for drinking Mountain Dew.
All right, so how does our body keep all this in check? Well, we have two primary systems which function to regulate the acid-base balance in our bodies. We have the respiratory system, and then we have our kidneys. The respiratory system responds very quickly. It can respond and correct a pH change very fast. We talked about just a second ago how we take that buffer and break it into carbon dioxide and water. All right, the carbon dioxide we're going to breathe out. So if we had a issue where we were very acidic, if our body was acidic and we were trying to correct that, what would you expect to happen with our respirations? They would go up. All right. Your kidneys play a very complicated and complex role in the regulation of your pH system, and they are very slow acting. All right, your kidneys are going to be doing their functioning over a period of hours. They don't respond immediately like your respiratory system does. What the kidneys do basically is they will excrete hydrogen ions or bicarbonate ions as needed. All right, your respiratory system generally only corrects the acidosis. All right, it doesn't really do very well with correcting alkalosis. All right, because think about it. Okay, if we want to decrease our pH, all we have to do is what? Right, breathe faster. All right. So on the opposite side, if we wanted to increase our pH, what would we do for that?
Breathe slower.
Breathe slower.
Stop breathing.
The problem with that is you reach a point where that doesn't work out anymore for you. All right. So we can if say normal breathing is between 12 and 20. You know, if we're breathing 30, that's not great, but not going to kill us either. But if normal is 12, and we say, okay, I'll breathe 4, it doesn't work. There are 4 primary acid-base imbalances that you will encounter. They are respiratory acidosis, respiratory alkalosis, metabolic acidosis, and metabolic alkalosis. Your respiratory acidosis occurs when the exhalation of CO2 is inhibited. Does that make sense? You have acidosis because of an increased amount of acid in your blood, and it's respiratory because it's not eliminating CO2 properly. What could be some of the causes of respiratory acidosis?
Respiratory distress.
What was it? Hypoventilation.
Inadequate breathing.
I'm sorry?
Inadequate breathing.
Inadequate breathing.
I guess when breathing
Cardiac
stops
arrest.
altogether.
Cardiac arrest. How about, y'all are thinking about the rate of ventilation.
Carbon dioxide poisoning.
What about gas exchange? What if you have a condition, for example, and that can occur in people who are spazzing out, having a panic attack. Can occur in, diabetics. It can occur in trauma patients with a head injury. All right. They may be breathing rapidly for whatever other reason, okay? But the result of that is going to be the change in their body's pH. All right. Metabolic acidosis is a condition in which the level of bicarbonate is low in relation to the levels of carbonic acid.
Meaning that it broke that 1-to-20 ratio.
Right. I have a really neat picture that's going to hopefully illustrate that a little bit better. All right. Metabolic alkalosis occurs when the level of bicarbonate is too high.
Right.
Showing that he's having a decrease in respiration, which is a decrease in the exchange of carbon dioxide, and the carbon dioxide is building up in his system, which is then keeping his system acidic. All right, because going back to what I drew on the board, your body gets rid of the excess acid by converting it into carbon dioxide and then breathing it out. Well, if you can't breathe it out, you're still retaining all that acid. What? Fix the breathing. Fix the breathing. Alright. Respiratory alkalosis occurs when the respiration gets too high. Alright. When you start breathing off too much carbon dioxide, it's going to raise the pH of your body because you're blowing off excessive amounts of carbon dioxide. Alright. Remember, there should only be 20 bicarbonates to every carbonic acid. All right, the HCO3 is the bicarbonate, and the H2CO3 is carbonic acid. How you can remember that in your mind is acid has to do with too much hydrogen, right? You have more hydrogen, you get more acidic. We're comfortable with that, right? If you look at these two formulas, they're the same, except for this one has one more hydrogen. So the one with the extra hydrogen is the acid. All right, so we need to have 20 bicarbonates to every one carbonic acid. Now, this is going to be acidosis because we have 3 carbonic acids. We have our 20 bicarbonates like we're supposed to, but unfortunately we have an extra 2 acids, so therefore our system is out of balance. Some of the different things that will cause that are starvation. That's why eating is important. Generally not a problem with folks who work in EMS. Diabetes is another condition in which you cause your body to become too acidic. On the flip side, remember it's supposed to be a 20-to-1 ratio. We need 1 of these and 20 of these. 1 of this one we're in alkalosis because we have 36 of them. Or if we're supposed to have 20, we have 36. How do you suppose we get too much of this? What? Eat too much what?
Salt.
Like, yeah, bicarbonate. Like Tums.